Good day everyone. So for today we are here to discuss about the photovoltaic system. So what is photovoltaic system? A photovoltaic system is composed of one or more solar panels combined with an inverter and other electrical and mechanical hardware that use energy from the sun to generate electricity. Photovoltaic system can vary greatly in size from a small rooftop or portable system to massive utility-scale generation plants. Although photovoltaic system can operate by themselves as off-grid photovoltaic system. So how it really works? Photovoltaic system use photovoltaic cells to collect solar energy from the sunlight and converts it into direct current electricity, which the reflection of the sunlight will create an electric field across photovoltaic system, causing electricity to flow. The DC electricity will transported to an inverter, which will convert this DC power to alternating current. This AC power is the type of electricity which is used to electric appliances in your home, also referred to as AC load. So let's move on. Pagdating naman sa ating photovoltaic system, ano nga ba mas magandang gamitin? Monocrystalline o polycrystalline na solar panel? So tara, ano ba mas the best? Alamin natin. The main difference between the two technologies is the type of silicon solar cell they use. Monocrystalline solar panels have solar cells made from a single silicon crystal. In contrast, polycrystalline solar panels have solar cells made from many silicon fragments melted together. When comparing solar panels when it comes to cost, monocrystalline solar panels are more expensive than polycrystalline solar panels. That doesn't mean they may not be your best option. The silicon structure is the main factor determining the cost differences between the two solar panel types. Manufacturers pour molten silicon into square molds to produce polycrystalline panels, then cut the resulting wafers into individual cells. Conversely, to produce monocrystalline panels, the solidification of silicon must be controlled by very carefully, which is more complex process. This makes single crystal solar cells more expensive. When it comes to lifespan, the two has similarities and can perform up to 25 years, but when it comes to efficiency, they have a big differences. And in general, monocrystalline solar panels are more efficient than polycrystalline solar panels because they cut from a single crystal of silicon, making it easier for the highest amount of electricity to move throughout the panel. And monocrystalline solar panels can reach efficiencies of over 23%, and in some instances, while most polycrystalline can perform an efficiency of below 20%.
So, good day po everyone. So, ang pag-usapan po natin is itong tinatawag nating solar cell or yung tinatawag nating photovoltaic cell. So, ano po ba yung solar cell na tinatawag? So, sabi po dito, solar cell or photovoltaic cell is a device that is made up of semiconductor materials such as silicon, gallium arsenide, and cadmium telluride that converts sunlight directly into electricity. So sabi po dito, when solar cells absorb sunlight, free electrons and holes are created at positive or negative junctions. If the positive and negative junctions of solar cell are connected to the direct current or DC electrical equipment, current is delivered to operate the electrical equipment. So ito po yung tinatawag nating solar cell. At ano po ba yung nagko-compose sa tinatawag nating solar cell? Ito po yung composition ng solar cell natin, which is composed po siya ng glass, anti-reflection coating, kung makikita natin dyan sa slides, metal grid, and meron po tayong two types ng silicon, which is N-type tsaka P-type po, and then yung pang last is metal plate po. So sabi po dito, next slide po natin, let us start on the first thing that is happening inside a solar cell when sunlight strikes it. So, maaari pong nagtatanong siguro or nagtataka kayo, ano po ba yung nangyayari sa sunlight which nako-convert siya into electricity or sabihin natin voltage kapag tumama sa solar cell. So, sabi po dito, for maximum efficiency to occur, the solar panel must absorb as many energy as it can from the sun. So ito po yung process ng solar cell natin. I-absorb daw po niya yung kaya niyang i-absorb na energy mula sa sun. And then, sabi po dito, the more energy it's absorbed, the more energy it can supply. So yun po yung process niya. Kapag sobrang, kaya nga po mas efficient ang solar panel kapag tanghaling tapat. Bakit po? Kasi kapag tanghaling tapat, andyan po yung pinakang maximum power ng sun na kung saan kapag tawag ko dito, nag-absorb itong solar panel natin, is talagang makukuha po niya. At sabi dito, the more energy or the more energy na na-absorb ito sa sun, ganun din po energy yung kaya nitong isupply. Sabi pa po dito, here is the thing. Somewhere around 5% of energy from the sun is already lost due to reflection once it hit the glass, which is the top layer. So, titignan natin, bagamat hindi naman po gaano halata kapag tinignan natin isang solar panel. Pero meron po itong glass na kung saan sabi dito, meron pong 5% na nawawala kapag nagtumama na po yung sabihin natin yung sunlight sa solar panel natin by cause of reflection po. So, mawawala na po yung tinatawag natin na nawawala yung 5%, halos 5% po ng sun rays po natin. So, sabi po dito, to avoid, next slide po natin, to avoid further losses of sun's energy upon re-entering the glass, this is where the anti-reflection coating comes into play. So, sabi ko nga po kanina, ang composition ng solar cell natin is yung unang layer niya is glass. Susunod, papasok po yung anti-reflection coating. So, ano naman po yung ginagawa nitong anti-reflection? From the word itself po, anti-reflection. So, sabi ko nga po kanina, or sabi sa slide kanina, may nawawalang 5% po, di ba? Kapag tumama yung liwanag ng araw dun sa solar cell, kasi sa glass po na naka top coat dito. So, ito po yung tawag dito. Ito pong sumunod na parts is yung tatawag nating anti-reflection, na kung saan ito po yung ginagawa niya. Lets the light, anti-reflection coating lets the light in, but mostly it doesn't let the light to be reflected out. So, yun po yung process niya. Pinapapasok po niya yung liwanag, pero hindi na po niya pinapalabas muli. Sabi po dito, it doesn't let the light to be reflected out. Ano pong gagawin niya? It also makes some of the reflected light to get back. So, paanong process po yun? Malalaman po natin sa susunod na slide. Sabi po dito, certain manipulation is being done during manufacturing to achieve that characteristic. So, yun po yung, ito po yung pinakang mahalagang parts. So, sabihin natin, kasi nga po kapag walang anti-reflection yung isang solar cell natin, eventually marami pong masasayang na energy na galing sa sun. Kaya ito po yung purpose o importance nitong anti-reflection coating natin, na kung saan inaalaw po niyang pumasok yung energy pero hindi niya na po inaalaw lumabas. Bakit po? So, ito po pag-usapan natin. Ito po yung nangyayari sa anti-reflection. Next slide po natin. Sabi dito, scenario to be avoided to prevent losses due reflection. This happens when coating is incorrect. Waves are aligned and waves are misaligned. Sabi po dito, with the right amount of coating, the reflected energy can be minimized if not totally cancelled. So, ito po yung isa sa dapat nating consider na makita sa mga solar cell. Kapag incorrect daw po yung pagkakalagay, pwede pong ma-misalign yung mga solar sun rays po natin or sun energy natin. And then, kapag na-misalign po yan, pwede pong may part na lumabas o tumakas yung energy na nakuha na po ng solar cell. So, ito po yung kahalagahan ng tinatawag natin na solar cell or yung parts niya na composition. Bagamat hindi na po nabanggit yung iba pang parts, pero ito po yung pinakang mahalagang parts niya, kung saan dito po tumatama yung araw sa glass, and then kapag na-absorb na po ng glass, papasok sa anti-reflection coating natin, which is inaalaw nga po niya pumasok pero hindi niya na inaalaw lumabas. Ang gagawin na po niya, doon niya na paglalaruin yung energy sa loob. So, alam naman po natin sa mga naunang topic natin kung paano tawag ko dito, paano nag-work itong solar panel dahil sa pag-absorb nito ng energy po.
What is photovoltaic effect? The photovoltaic effect is the generation of voltage and electric current in a material upon exposure to light. It is a physical and chemical phenomenon. To achieve a photovoltaic effect, we need a material which, when struck by sunlight, will exhibit some characteristics of a conductor. Review question. What is happening inside the copper conductor when there is no presence of voltage across it? The answer is, its valence electron is free to move, transferring from one atom to another in random. The particular characteristics of a conductor where there are a number of electrons that moves freely is what should be attained to exhibit photovoltaic effect. This is where the silicon semiconductor comes into play. When the silicon semiconductor absorbs energy from the sun, the photons which the sunlight have could knock an electron out of its orbit within an atom, making it free to move within the system in random. Here's another question. What substance should be used as dopant for the silicon to become negatively charged? And what substance should be used as dopant for the silicon to become positively charged? The answer is, on the N-type side, phosphorus is being used as the doping materials, while on the P-type side, it's boron.
So ayun nga, N-side is phosphorus with 5 electron in outer shell. So ito yung magbaban sa silicon. So merong extra electron kaya naging negative charge. Then sa P-side naman is boron, have 3 electron in outer shell. Dito naman missing ng isang electron, so meron tayong open spot or yung tinatawag na hole. Since there is a rush of electron from the N-side towards the P-side, the charge of the two sides will be reversed, making the boron dope P-side becomes slightly negative, and the phosphorus dope N-side slightly positive. So, nagkapalit ng charge, and after that, magkakaroon ng depletion region. So, depletion region, ito yung region kung saan walang free electron and holes. So, it is a barrier. So, mag-i-stop muna yung process and an electric field is definitely created. So, the silicon PN junction is now exhibiting characteristics of battery. So, sunlight enters the N-type side, then penetrates the depletion region. This process knocks an electron out of the band as many as it can, creating a pair of free electron and holes in the depletion region. The electric field drives the pair out of the depletion region. The free electron goes into the N-type side and holes in the P-type side, resulting in higher concentration of both. So, back to normal form. So, babalik kung saan kabilang yung free electron and yung holes. Practically, in a solar panel, the top layer, which is the N-type side, is thin and heavily doped, while the bottom P-type side is thick and lightly doped. So, meaning, mas marami yung phosphorus kaysa sa may boron. Because of that, mas magiging maluwang yung depletion region. And yung free electron and hole pair is being generated in a wider area, which in turn produces more electricity. So, dito naman tayo sa may operation sa solar power plant. So, sunlight goes to the solar panel. And then, alam naman na natin kung paano nag-operate yung solar panel. Since direct current yung generate ng solar panel natin, so need natin ng inverter to convert it in AC. So, yung inverter, ko-connect natin sa AC service panel and AC meter. Then, i-step up to prevent losses due to long transmission line. So, step-up transformers are required to boost the 480 to 690 volts inverter output voltage to the 13.8 kilovolts to 46 kilovolts of the medium voltage utility network. It is then connected to a substation for distribution into residential area.